All right, guys. Any questions on the homework?
3 on.
Which is?
3x squared plus 3x minus 6.
Is there a greatest common factor? So we factor 3 out. Two sets of parentheses with 3 spaces. Yep, so x and x. Since the middle term is positive, we'll want 2 and 1. If we check this here,
Yeah, that's what I got confused on.
negative x plus 2x is, and that's it. Questions on this here? So finding the quadratic formula, or the quadratic formula itself is derived from ax squared plus bx plus c is equal to 0. We can get it from this formula here. Now, I'm going to work it through for y'all here. I worked it through for third hour. I didn't do it for fourth hour. But I'm going to go on and show you guys this. So you don't have to write any of this down. Just go on and just kind of watch and see how we get this. And again, I'm showing this to you so that you know where the formula comes from and not just given the formula. Now, what we're going to do is apply completing the square to this here. Because ax squared plus bx plus c is any quadratic. Any quadratic that we can have is going to come in this form here, where a, b, and c are real numbers. With the quadratic formula, the first thing we needed was that a, the number in front of x squared, had to be 1. So we can divide everything by a. Telling us that we have x squared plus b over a times x plus c over a is equal to 0. Our second step was to get the constant term by itself, which will tell us that we have x squared plus b over a x plus blank is equal to negative c over a blank. Now our c term, to make this a perfect square, is b over a, but in this case it's going to be b over a over 2, which actually works out to be b over 2a, and if we square this, we get b squared over 4a squared. And as funky as this looks, especially if we're thinking we're trying to factor this, again, the way that we factored it the other day still holds true. It's going to be x plus b over 2a. What was inside the parentheses before we squared it. Over here, we needed to actually get the a's, the denominators to be the same. So we would multiply top and bottom by 4a. 4a times a is 4a squared, so the denominators are the same. On top, we're going to have b squared minus 4ac, because the negative c times 4a would be negative 4ac, and we can combine them here. At this point here, we would square root both sides. These two will cancel, telling us x plus b over 2a is equal to plus or minus. On top, we're going to have the square root of b squared minus 4ac. On bottom, the square root of 4 is 2. The square root of a squared is a. And last but not least, we can subtract b over 2a from both sides, which will tell us x is equal to, I'll scroll back up so we can kind of see it, 2a plus or minus the square root of b squared minus 4ac. Well, since the denominators are the same, we can add and subtract the numerators. And we get this here, which is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I showed you all that so that you guys have an idea and understanding where this formula comes from. So it's just not a formula that you're given. You have an idea of where it started. Okay? And we're going to use it to solve these equations here. So this is the first one we're looking at. Solve x squared plus 3x equals 5 using the quadratic equation. Well, the first thing we need to do is get this equal to 0. So we're going to subtract 5 from both sides, telling us that x squared plus 3x minus 5 is equal to 0. Questions on this here? Okay. Now we're going to plug in the values of a, b, and c. And again, so for b in our case, what's its value going to be? 3. It's the number in front of x. We take the sign with it. Since it's plus, I'll plug in positive 3. Plus or minus the square root. B squared, so it would be 3 squared. Minus 4 times a. Well, the value of a is 1, yes? 1 times c, which is negative 5. Questions on this so far? Now it's all over 2a, so 2 times a, which is going to be 2 times 1. Questions on this here so far? Okay. Now we need to do some simplifying. So the first part, the negative 3, is just going to be negative 3, yes? Okay. Plus or minus? Square root. Now it'd be very tempting, it is very tempting to want to plug everything, the whole square root and everything inside into the calculator. I would be hesitant to do that partially for, well, 2 reasons. One, we know already that we can have solutions where that radical is not going to come out to be a nice number. Because if we get anything that's not a perfect square inside the radical, it's going to come out as a decimal if we plug the square root of 3 squared minus 4 times 1 times negative 5 into the graphing calculator. So that doesn't work well. So we could plug it into the 30xs, the yellow calculator, which it would simplify it in radical form as long as whatever b squared minus 4ac is either equal to 0 or greater than 0. Because if it's a negative, it's going to say it's not a real solution, which means I'll have to remove the square root, figure out what it is, and then go from there. So in either case, it's easier to just take the calculator, clear all that out, clear that, and say 3 squared minus 4 times 1 times negative 5. Okay, it's 29. In either calculator, we can get that. If we do it in the yellow calculator, okay, 29, I can go second square root 29, hit enter, and see that it is, just see that it's still the square root of 29. And 2 times 1 is 2. There are no like terms. There's no way we can reduce this, so this here is our answer. Any questions on this here? Any questions on anything we've done so far? Are you ready for the next one? If we're using the square root method, the first thing we need to do is what? I need to get it equal to 0, so we can subtract 10 from both sides, telling us 3x squared plus 4x minus 10 is equal to 0. So again, we're plugging in A, B, and C. So we could say negative 4 plus or minus the square root of 4 squared minus 4. A in this case is 3, and C is negative 10. And it's all over 2 times 3. Now we need to simplify. Well, we'll have negative 4 plus or minus. In the denominator, 2 times 3 is 6. Inside the square root, we have 4 squared minus 4 times 3 times negative 10. 4 squared minus 4 times 3 times negative 10. So we have 136. Questions on how we got to this point here? Now, we can plug 146 into the yellow calculator to see if this would reduce. And does it? 2 radical 34. 2 times square root of 34. Yep, nope, radical and square root are the same thing. Now, is there a like term between negative 4, 2, and our 6? Yeah, they all have 2, yes? So we could, one of the 2 ways we can do it is we can factor 2 out of the top. Then we'd have 2 over 6, which is 1/3, and we can simplify that way. The other method is to, whatever that common factor is, divide every space by it. So negative 4 divided by 2 is going to be negative 2. 2 square root of 36, 2 square root of 34 divided by 2 is just going to be square root of 34. And 6 divided by 2 is 3. Now, if it simplifies out completely in one of the spots, especially the denominator, it's just going to simplify to 1. If it divides out completely, it'll just divide to 1. And especially if the denominator where 3 is, if that had simplified out completely, we just wouldn't put a denominator. It'd be whole numbers. Questions on this here? How do we feel about these here? Do we need to see another one? No, we're good with this? Because, I mean, well, we'll see more. We just, instead of doing this one, we'll do this one here. Because we're going to do 2 more, we just won't do those 3. We're going to look at these 2 mainly because they have some special properties or special things that happen. Because the main thing with this is we're plugging in for the values of A, B, and C and simplifying. Now for this one here, we do need this equal to what? So what can we do first? Yeah. So 25x squared minus 20x plus 4 is equal to 0. So negative b, which would be negative 20. So we'll have negative parentheses, negative 20, close parentheses. Now, if you wanted to, and I do this a lot of the times, the negative b, I'll go on and simplify it. Because here, negative 20, I would just write 20, positive 20. I don't just write it out as this here. Now, this radical, I still, even when I'm working these, still write this out. Times 4. Because switching or doing negative b and simplifying, that's not hard. We're just applying a negative. The denominator, 2 times a, so this is going to be 2 times 25. I would simplify that to 50. Because multiplying by 2, applying a negative, those aren't bad. I can do those in the same step that I plug them in. Because here, this would be 20 plus or minus over 50. Now at this point here, we would plug in parentheses, negative 20, close parentheses, squared, minus 4 times 25 times 4. And if we type that in, we get 0. Yep. What's the square root of 0? What's 20 plus 0? What's 20 minus 0? 20. Is adding 0 or subtracting 0 doing anything? So we don't even need any of that there. So it's really just telling us that it's 20 over, which is simplified to 2/5. And that would be the answer. We technically still have 2 answers, they're both just 2/5. So, but that's it. Questions on this here? Questions on anything we've done so far? Here's our next one. What do we need to do first? Subtract 13. This will tell us that we have negative x squared plus 4x minus 13 is equal to 0. Do we need to do anything else? No. I mean, we can leave a as negative 1. That's fine. I got ahead of myself. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll have negative b, which is going to be negative 4, plus or minus the square root of b squared, which is 4 squared, minus 4 times a is negative 1 and c is negative 13 over 2 times negative 1. Questions on this so far? Now we'll need to simplify it, so we would have negative 4 plus or minus our square root. The denominator, 2 times negative 1, is going to be negative 2. Now we can plug this all into the calculator, and we would get negative 36. Yes. This is going to be one of the ones where trying to type the whole thing into the yellow calculator would throw back an error, because it can't find the square root of negative 36. Now the negative would indeed come out as I, which leaves us with the square root of 36, which is 6, yes? Do all 3 have a common factor? They all have a common factor of 2. And we could divide each term by 2, but I wouldn't just divide it by 2, I would divide it by negative 2. So negative 4 divided by negative 2 is 2. Well, we have plus and minus 6, yes? Well, the positive case, if I divide it by a negative, it becomes negative. If I divide the negative by a negative, it becomes, so it's still plus or minus. The positive becomes negative, the negative becomes positive, which still gives us plus or minus. 3i. And lastly, we have the denominator. Negative 2 divided by negative 2 is 1, positive 1, which means we just have this here. Because when the denominator itself is the common term between all three, it's going to simplify out completely and just become 1. So we could have said that this is 2 over 1, or 2 plus or minus 3i all over 1, but that's just 2 plus or minus 3i. Any questions on any of this here? We kind of like this here. I would say this is the second easiest method for solving quadratics. The first is graphing. Because if we can graph it, it's just wherever it crosses the x-axis. But out of all the ways that work, I feel like this is a little bit easier than completing the square. Any questions on any of this here? So you ready for the next part? The discriminant. Now the discriminant is our b squared minus 4ac. And this has three main properties to it. If b squared minus 4ac is greater than 0, we have two real solutions. Now b squared minus 4ac is equal to 0. We have one real, we would say unique solution. And if b squared minus 4ac is less than 0, we have two, I say complex solutions. The book says imaginary solutions. Both are correct. Because we can say they're complex or imaginary. Either way, we get an I term. Questions on this here? So if we figure out what the value b squared minus 4ac is, it'll tell us what kind of solutions we should have. So let's look at these here. So for the first one here, we're finding the value b squared minus 4ac. Well, b in our case is negative 6 squared minus 4. A is 1 and c is positive 10. At this point here, we could plug it into the calculator. Negative 6 squared minus 4 times 1 times 10. And it is negative 4. So is the value of the discriminant greater than 0, less than 0, or equal to 0? So it tells us that we have two complex or imaginary solutions. And that's it. Now we could use it to find what the actual solutions are, but I'm going to leave it at this here. Questions on the first one? Let's look at the next one. B squared minus 4ac. Well, B is still 6. A is still 1, but this time C is 9. And in the calculator, we can do it again. But this time, instead of having 10, we have 9. Well, negative 6 squared minus 4 times 1 times 9 is 0, which means we have one real solution. And last but not least, so we're wanting to find out what b squared minus 4ac is for this here. Well, the value b in this case is negative 6 squared. Yep. Minus 4 times 1 times 8. And this time it's going to give us 4, which means we have two real solutions. And we know it's two real solutions because the value of the discriminant is greater than 0. And that's it. Questions on any of this here? Questions on anything we've done today? Y'all feel comfortable with this? That's it. That's all we're doing today. 6 through 16 even is just using this quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. 21 through 24, you want to find the discriminant's value. Find the discriminant, what b squared minus 4ac is. Determine the number of solutions, so either 2 or 1, and type, so either 2 real solutions, 1 real solution, or 2 complex solutions. And that is it.